Hi, this is your Professor Sudha Kolathuparambil, Section 8.2 Confidence Interval for a population mean when standard deviation unknown. In previous section 8.1, we learned how to construct a confidence interval for a mean of a normal population when the population standard deviation is known. Here in this section, it is unknown. So it has two objectives. Describe the properties of student t distribution and how to construct a confidence interval for the population mean when the population standard deviation is unknown. Let's look at what is student t distribution. In the previous section, when sigma is known, we construct the confidence interval using this formula. And the critical value, we use this formula. And it has a normal distribution. But in practice, it is common that sigma is unknown. When we don't know sigma, replace the sigma with the sample standard deviation S. S is a bit smaller than sigma. So replacing sigma with S tend to increase the magnitude of this overall magnitude. So right now we have S divided by square root of n. Since S is smaller than sigma, this entire quantity will increase in magnitude. Now we cannot use z alpha over 2 as the critical value because this quantity does not have a normal distribution. So distribution of this quantity is called the student t distribution. There are many student t distribution and they are distinguished by the degrees of freedom. When using the student t distribution to construct a confidence interval for population mean, the number of degrees of freedom is 1 less than the sample size. Student t distributions are symmetric and unimodal, just like normal distribution. However, they are more spread out. The reason is that S is on average a bit smaller than sigma. Also, S is random whereas sigma constant. Replacing sigma with S increase the spread. When the number of degrees of freedom is small, the tendency to be more spread out is more pronounced. So the t distributions are much more spread out than normal. When the number of degrees of freedom is large, S tend to be very close to sigma. So the t distribution is very close to the normal. So in this diagram you can see the amount of the spread decreases as the number of degrees of freedom increases. So in summary, the student t distribution has the following properties. It is symmetric and unimodal. It is more spread out than the standard normal distribution. If we increase the number of degrees of freedom, student t curve becomes closer to the standard normal curve. Let's see how to find the critical value. Here we are using t instead of z because we are using the student t distribution to construct the confidence interval for mu when sigma is unknown. The idea behind the critical value is same as the one for the normal distribution. To find the critical value for a confidence interval with a given level, let's say 1 minus alpha. So this will be the confidence level expressed in decimal. Assume that the confidence level is 98%. So this area will be 0.98. So remaining area, the sum of these two area will be 100% minus 98%, right? So that will be 2%. Since these two areas are same, so area of one of these will be 2% divided by 2, that is 1%. So 1% in decimal is 0.01. So area of these two shaded part will be 0.01. Or I can say alpha over 2, that is 0.01. So the critical value is t 0.01. So in order to find the critical value, look at the table A3. Assume in this example n equal 4 is given. So number of degrees of freedom will be n minus 1, that is equal 3. So look at the row, the number of degrees of freedom 3, and the column 0.01, and find the intersection of those two. In this example, we want to find a critical value, 95% confidence level. Sample size is given, that is 10. First draw the student T curve. So this is 95%. So remaining area, these two will be 5%. Then this area on the right side of the student T distribution is 5% divided by 2, because these two areas are equal. So that is 2.5%. 2.5% in decimal is 0.025. So this is alpha over 2. So this area is 0.025. Now we need to find the critical value. So we have n minus 1 degrees of freedom. So n minus 1 means 10 minus 1, that is 9. So 9 degrees of freedom and 95% confidence level. 95% of the area under the student T curve with 9 degrees of freedom is between negative T 0.025 and T 0.025. So we will use the table A3 to find the critical value. So in the table, look at the row degrees of freedom 9 and the column 0.025 and find the intersection. So the critical value T alpha over 2 is 2.262. What if the number of degrees of freedom is not in the table? The largest number of degrees of freedom in the table A3 is 200. If the desired number of degrees of freedom is less than 200, then use the next smaller number that is on the table. If the desired number of degrees of freedom is greater than 200, then use the z value found in the last row of the table. But you can use calculator or computer because they can calculate the critical values for any number of degrees of freedom. Let me summarize this. If n minus 1 is less than 200, then use the next smaller number in the table. Use the next smaller number. If n minus 1 is greater than 200, then use the z value in the last row. The following are the assumptions that are necessary to construct confidence intervals by using student's tree distribution. We have a simple random sample. Either the sample size is large, that means n is greater than 30, or the population is approximately normal. When the sample size is small, that means when n is less than or equal 30, we must check to determine whether the sample comes from the population that is approximately normal. We can check this using the dot plots or box plot. If there are no outliers, And if the sample is not strongly skewed, then it is reasonable to assume that the population is approximately normal. And it is appropriate to construct a confidence interval using the student t distribution. In objective 1, you learn what is a student t distribution is and how to find the critical value of student t distribution using table, and the assumption for constructing a confidence interval using the student t distributions. Now let's look at the procedure of how to construct the confidence interval for the population mean when the population standard deviation is unknown. If the assumptions are satisfied, the confidence interval for mu when sigma is unknown is found using the following steps. First, compute the sample mean and sample standard deviation S if they are not given. Then find the number of degrees of freedom and the critical value. And compute the standard error and multiply that by the critical value. Actually multiply the critical value and the standard error. Okay, that is the margin of error. Then add that with the mean. So you will get the interval. So here you can see the procedure is almost same as the previous chapter. The interval is point estimate plus or minus the margin of error. So point estimate is x bar, the sample mean, then plus or minus t alpha over 2 s over square root of n. In this example, the number of calories in a sample of 8 cookies are given. We need to find a 98% confidence interval for the mean number of calories in this type of cookie. First, we will check for the assumption. We have a simple random sample. Since the sample size is small, the population must be approximately normal. We check this with a dot plot of the data. There is no evidence of strong skewness or no outliers, so we can proceed. The confidence interval is x bar plus or minus t alpha over 2 s divided by square root of n. So we need to find the mean and standard deviation. I am going to use the calculator to find the mean and standard deviation. So press stat, edit, and enter these values: 113, 114, 111, 116, 115, 120, 118, 116. Then press stat, calc, and one more. We are using list 1, so calculate. So now I find the mean, that is 115.375, and the standard deviation 2.8253. So I'm going to write down these values. Now we need to find the critical value at the 98% confidence level. So this area is 98%. So sum of these two areas will be 2%. So this will be 1%. So this area is 0.01. So I need to use the table 3. And I'll be looking for the degrees of freedom n minus 1, that is 8 minus 1, that is equal 7. And corresponding column 0.01. So this is the row I am looking, this is the column I'll be looking to find the critical value. So using the table, we know that degrees of freedom 7, and at the column 0.01, this is the critical value. Therefore T alpha over 2, that is 2.998. Now we will substitute all these values into this formula to find the confidence interval. So I'm going to copy these values to the next page. I copied the information from the previous slide. Now let's construct the confidence interval. Now I substituted these values and I calculated this. Since it has plus or minus, it will have two values, one with the minus sign, other with the plus sign, and I rounded the final result to one decimal place because the sample values were whole numbers. Now we need to interpret the result. We are 98% confident that the mean number of calories per cookies is between 112.4 and 118.4. Let's look at another example and highlight the important information while reading. A sample of 123 people aged 18 to 24 reported the number of hours they spend on the internet in an average week. The sample mean was 8.20 hours with the sample standard deviation 9.84 hours. Assume that this is a simple random sample from the population of people aged 18 to 22 in the US. We need to construct a 95% confident interval for mu. So n is 123 people, sample mean that is x bar, sample standard deviation this is s. So here sigma is unknown. So we will be using the student t distribution to construct the confidence interval. First we need to check the assumption. We have a simple random sample n equal 123 which is greater than 30. So sample size is greater than 30. So the assumptions are met. So the interval will be point estimate plus or minus t alpha over 2 the critical value times s over square root of n. So this is the margin of error. So point estimate plus or minus the margin of error. So in this we know x bar as we know n, but we don't know the critical value. So we need to find the critical value. In order to find the critical value, we need to find the degrees of freedom. The number of degrees of freedom is n minus 1. So n minus 1 is 122. So confidence level is 95%. So this is 0.95. So remaining area that will be 5%. So 5% divided by 2 that is 2.5%. So this area will be 0.025 in decimal. So we know that in table A3 we need to look at the row which correspond to 122 and the column correspond to 0.025. This number, the number of degrees of freedom 122, this number is not in the table. So we will use the next smaller value in the table which is 100. So the critical value correspond to 95% confidence level is 1.984. So we are looking at the row which correspond to 100 and the column 0.025 to get the critical value. Now we substitute all these values into the formula to find the confidence interval. S is 9.84 divided by square root of 123. If you subtract, you will get 6.44. If you add, you will get 9.96. So you will get two values. So now we can interpret the result. We are 95% confident that the mean number of hours per week spent on internet by people 18 to 22 years old is between 6.44 and 9.96. Now let's find a confidence interval for a population mean when sigma is unknown using a TI-84 calculator. First press stat, then use the arrow key, select test, use the arrow key and select option 8 T interval, or you can just press 8 then press enter. Then highlight stat using the arrow key, press enter, then input sample mean, sample standard deviation and n. So x bar is 8.2 in our previous example and s is 9.84 and n is 123 and confidence level is 95%, so 0.95, 0.95. Okay, then highlight calculate and press enter. If you round this value into 2 decimal places, it will match with our answer we found without using the calculator. In this section, you learn the properties of the student T distribution and how to construct and interpret the confidence interval for a population mean when the population standard deviation is unknown. And the formula we used to construct the confidence interval for mu when sigma is unknown is x bar plus or minus t alpha over 2 times s over square root of n. And we use table A3 to find the critical value.